Okay, so hopefully you calculated this on your own, but I'll just summarize it very quickly. Delta theta is omega delta t, as it was in the last calculation. Now omega is, the new omega is negative 0.22 radians per second, so we multiply that by our 0.001 second, and we still get a minuscule number of radians. And I never did write my new theta down here because I didn't kind of have room. I have to write that. But we would add that to our 11.9999 radians and get 11.9997 approximately, 11.999.9968, 99968, so that, yeah, be 99968. Okay, not much change in theta because, again, we're not moving very fast, and this is a pretty short time interval, right? Our change in omega is going to be, well, pretty much the same as before. Theta hasn't changed by much. The cosine of 1.2 and the cosine of 11.99, it's not 11.999. This should be 1.199911. Okay. Hopefully you noticed that. Fix that. It should be 1.1999 there. Okay, sorry. And if you used the 11 and so forth, you would have gotten something that made no sense. So my apologies in that. This is the way it should be. In any case, here's our new omega. Okay? It's changed by 0.12 radian per second to negative 0.34 radian per second. So if we step back and look a little bit, we see that we're actually building kind of significant velocity here, 0.34 radian per second. Well, that's about this fast. Okay, it's already fallen about this fast. And it's going to keep falling faster and faster. Remember, we're only calculating in milliseconds. This is only after 2 milliseconds. It's already moving about this fast. Now, it hasn't moved very far because even at this fast, 2 milliseconds doesn't give it time to go very far. But as time goes on, it's going to go faster and faster and faster, which means it'll move further and further and further with each new millisecond. Which means that eventually this angle is going to start changing more significantly, and after enough steps, and I think this takes, between 150 and 200 steps, but after about 150 or 200 steps, this angle theta will have decreased to 0, and the speed will have increased very significantly. This negative 120 radian per second squared alpha value won't change much until the value of theta starts changing significantly. Okay, not much difference between this and this. And for quite a while, we're not going to see much difference in this angle, so we're not going to see much difference in this result. But when that angle starts changing more significantly, this result is going to come up closer to 300. Okay? Now, we can put these results into a table, and the table can show us the sequence of calculations. And once we put these in a table, we begin to see how we might want to put them into a spreadsheet like Excel. So what's the order of our calculations? Well, we have theta and we have omega. That's what we started with. What do we do with theta and omega? Well, there's several things we can do. We've got theta. We could calculate alpha right away. Maybe we want to do that. But I'm going to go with, we're going to use omega with delta t to find delta theta. So we're going to find our delta theta because that's the first thing we did when we calculated over here. So we're going to kind of follow the sequence of steps. So the delta theta is pretty easy to calculate. Then we want to calculate our delta omega, but that's going to require alpha, so we're going to have to calculate alpha. Now we can calculate delta theta because we know omega, and delta theta is going to be omega times our delta t. We can calculate our alpha because the formula for alpha is given in terms of theta. If we know theta, we can find alpha. Then, knowing alpha, we can find delta omega. So now we can find our new omega and our new theta. And these new values will become the values of omega and theta in our next line. Well, I'll write down the numbers here. Actually, it'd be very useful for you, if you're not real clear on this, to write down these numbers yourself. We start with theta equals 1.2 and omega equal negative 0.1. Then we calculate delta theta based on these values and delta t, and it probably helps to have delta t up here. And then we calculate alpha, which just uses theta. Calculate delta omega, which is going to use alpha and delta t. Calculate the new omega. Now, that's a really simple calculation, and for a very simple reason, but people have often asked me, how do I calculate the new omega now that I have all this in my new theta? The new omega is whatever omega you started with plus however much it changed. You take a value and the change in the value and you add them together, you get the new value. And the same thing with theta. Now actually when I did this, I calculated my new theta first and my new omega, but it doesn't really matter what order. I probably should have put them down in the other order, because that's the order in which the delta theta and delta omega were calculated, but I wrote it down that way and it works just as well, because these are very simple calculations. So you should consider doing those before I come back.